Look up at the night sky. What do you see? A sea of twinkling stars, distant and mysterious. But one object shines brighter than the rest, a celestial beacon captivating our ancestors for millennia. That, my friends, is Venus, our nearest planetary neighbor. Often mistaken for a star, this celestial gem earns its nickname, the evening star, by gracing our western sky after sunset. Venus, however, is no star. It's a planet, a world unto itself, shrouded in mystery and veiled by a thick, swirling atmosphere. For centuries, astronomers gazed upon Venus, their imaginations running wild with thoughts of lush landscapes and perhaps even life. But as we would discover, Venus harbored secrets far more intriguing, far more extreme than we could have ever imagined. This isn't just a story about a planet. It's about scientific curiosity, about pushing the boundaries of human knowledge. It's about unraveling the mysteries of our cosmic backyard, and in doing so, learning more about our own planet Earth. So buckle up, space cadets, as we embark on a journey to our celestial twin, Venus. Venus is often called Earth's twin, and for good reason. They are remarkably similar in size and mass. Imagine Earth as a basketball. Venus would be just a hair smaller. But don't let the similarities fool you. Venus is a world of extremes. While Earth teems with life, Venus has a surface hot enough to melt lead. The intense heat would incinerate your spacecraft. The pressure would crush you like a tin can. And let's not forget the sulfuric acid rain. Venus may be Earth's twin in size, but its essence is a world apart. Venus is hot, seriously hot. Surface temperatures average a scorching 867 degrees Fahrenheit, or 464 degrees Celsius. Hot enough to melt lead, hot enough to turn your spacecraft into a puddle of molten metal. What makes Venus such a planetary inferno? The runaway greenhouse effect. Venus's atmosphere is predominantly carbon dioxide, trapping heat from the sun. Sunlight pierces the thick clouds, warming the surface. The CO2 acts like a blanket, trapping the heat and causing temperatures to soar. This extreme heat isn't just a curiosity, it's a stark warning. Venus's runaway greenhouse effect shows what could happen to Earth if we're not careful. Venus's atmosphere is as thick as a London fog, but instead of water vapor, it's composed primarily of carbon dioxide, a whopping 96.5%. This dense CO2 blanket traps heat like a giant solar oven, leading to the extreme temperatures we discussed earlier. But that's not all. Venus's atmosphere is also incredibly heavy, about 90 times denser than Earth's atmosphere at sea level. Imagine diving to the bottom of a swimming pool and then multiplying that pressure by 90. That's what it would feel like to stand on the surface of Venus. And as if the heat and pressure weren't enough, Venus's atmosphere also contains clouds of sulfuric acid. These aren't the kind of clouds you want to be caught singing in the rain under. They're highly corrosive, and while they don't reach the surface as rain, they do contribute to the planet's hostile environment. So, while Venus may be Earth's twin in size, its atmosphere is a completely different beast, a toxic and unforgiving shroud that has kept its secrets hidden for millennia. Section 5. The whirlwind above. Hold on tight because things are about to get wild. While Venus's surface is a scorching hellscape, its atmosphere is even more chaotic. The thick clouds that blanket the planet whip around at breakneck speeds, reaching up to 220 miles per hour, or 360 kilometers per hour, in a phenomenon known as superrotation. Imagine a hurricane-force wind, constantly circling the planet, faster than the fastest bullet train. That's superrotation, and scientists are still scratching their heads trying to fully understand it. One theory suggests that it's driven by the intense solar radiation Venus receives, creating powerful thermal tides in the atmosphere. These super-rotating winds aren't just a curiosity. They play a crucial role in shaping Venus's climate and distributing heat around the planet. They also create some of the most stunning and dynamic cloud formations in our solar system, visible through telescopes as swirling, ever-changing patterns. So, while Venus's surface may be a scorching desert, its atmosphere is a whirlwind of activity, a testament to the incredible forces at play on this enigmatic planet. Section 6. A toxic embrace. Venus's sulfuric acid clouds aren't just a minor inconvenience. They're a major contributor to the planet's extreme and hostile environment. These clouds, formed from sulfur dioxide released by volcanoes, create a global haze that reflects sunlight back into space, giving Venus its high albedo or reflectivity. Imagine a mirror reflecting sunlight back at you. That's what Venus's sulfuric acid clouds do, but on a planetary scale. They reflect about 75% of the sunlight that hits them, making Venus one of the brightest objects in our sky. But this reflectivity comes at a cost. The sulfuric acid clouds also trap heat, contributing to the runaway greenhouse effect that makes Venus so unbearably hot. They also create a highly corrosive environment, eating away at any spacecraft that dares to venture too close. So, while Venus's sulfuric acid clouds may create a stunning visual spectacle, they are also a stark reminder of the planet's extreme and unforgiving nature. Section 7. Pioneers of Exploration. Our fascination with Venus is not new. For centuries, astronomers observed this celestial neighbor, but it was the dawn of the space age that truly allowed us to pierce the veil and begin unraveling its secrets. One of the most ambitious early missions was the Soviet Union's Venera program. Launched between 1961 and 1983, the Venera probes were the first human-made objects to enter another planet's atmosphere, land on its surface, and transmit data back to Earth. Imagine the excitement, the trepidation, as these robotic explorers plunged into Venus's thick, hot atmosphere, sending back the first glimpses of this alien world. The Venera missions revealed a world far different from what we had imagined. They confirmed the extreme temperatures, the crushing atmospheric pressure, and the presence of carbon dioxide and sulfuric acid. They also sent back the first images of the Venusian surface, a desolate, rocky landscape sculpted by volcanic activity. These missions were pioneers, paving the way for future exploration and forever changing our understanding of our enigmatic neighbor. Section 8. Unveiling Secrets from Afar. While landing on Venus's surface remains a challenge, recent missions have taken a different approach, studying the planet from afar using sophisticated instruments and spacecraft. One such mission is NASA's Parker Solar Probe, which, while on its primary mission to study the Sun, has used Venus's gravity for multiple flybys, capturing stunning images and gathering valuable data about the planet's atmosphere and magnetic field. Another mission, ESA's BepiColombo, is on its way to Mercury but will make 2 flybys of Venus, using the planet's gravity to adjust its trajectory and studying Venus's atmosphere and magnetosphere along the way. These flyby missions, while brief, provide valuable insights into Venus's atmosphere, magnetic field, and interaction with the solar wind. They demonstrate the collaborative spirit of space exploration, with multiple agencies and missions working together to unravel the mysteries of our solar system. Section 9. Missions on the Horizon. The exploration of Venus is far from over. In fact, it's just getting started. Several new missions are in development, promising to revolutionize our understanding of this enigmatic world. One such mission is NASA's DAVINCI Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus, which will plunge through Venus's atmosphere, sampling its composition and taking high-resolution images of the surface. Another exciting mission is NASA's VERITAS, Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy, which will orbit Venus using radar to create 3-dimensional maps of the surface and studying the planet's geology and volcanic activity. These missions, equipped with cutting-edge technology and driven by the insatiable human thirst for knowledge, will provide unprecedented insights into Venus's atmosphere, surface, and evolution. They will help us understand why Venus, despite its similarities to Earth, took such a different evolutionary path, becoming the scorching, hostile world we know today. Section 10. Venus, a window to our past and future. Exploring Venus isn't just about understanding a neighboring planet, it's about understanding our place in the cosmos. By studying Venus's extreme climate, its runaway greenhouse effect, and its volcanic activity, we gain valuable insights into the delicate balance that makes Earth habitable. Venus serves as a stark reminder of the potential consequences of unchecked climate change, a cautionary tale written across the cosmos. By studying Venus, we learn not only about another world, but also about our own planet, its past, present, and potential future. So the next time you gaze upon the evening star, remember that it's not just a celestial beacon, but a scientific treasure trove, a world of extremes waiting to be explored. Let's continue to push the boundaries of human knowledge, to unravel the mysteries of our cosmic backyard, and in doing so, perhaps learn how to better protect our own pale blue dot.